Hello friends, welcome back to my channel. This is Ayali Bhattacharya and today we're going to study Introductory Probability as you can see on the screen. So let's start with the introduction. See, in most branches of knowledge, experiments are a way of life, right? But in probability and statistics, let me write it down. We concern ourselves with special types of experiments, okay? Special types of experiments. Now, what do I refer as special types of experiments? I'll come to it. We'll understand it by the examples, okay? But let me give a general idea. See, special type of experiments means these experiments will be conducted in repeated times. Repeated times. And how will be conducted? In identical situations. Is this clear? Now let's take a few examples to understand this concept better, okay? See, the first example I'll take is a coin is tossed. Okay, the first example is of a coin. A coin is tossed. Assuming that the coin does not land on the sides, there are two possible outcomes of the experiment, which can be head, and the next is tail. On any performance of this experiment, one does not know what the outcome will be. The coin can be tossed as many times as desired under homogeneous conditions, and this is called an experiment. Do you get it? The experiment is conducted in repeated times and in identical condition, so this can be called an experiment. Though this is a random experiment which we do not know the answer in advance, we will come to the types of experiment later. First, let's consider only experiment and let's take few examples. Let's take few more examples, okay? This was the first example. Now let's take a next example, which is a manufacturer produces 1 feet rulers. What is 1 feet? 1 feet is 12 inches. Okay? The experiment consists in measuring as accurately as possible the length of a ruler produced by the manufacturer. Now, due to the errors in production process, one does not know what the true length of the ruler selected will be. Suppose the length of the rulers vary between like 11 and 13 inches. Let's take 11 and 13 inches. The exact length should be 12 inches, but let's say it varies, the measurement varies between 11 and 13 inches. One must measure the length of the rulers as many times as desired under identical conditions. That will be called an experiment then. Why did we consider this as an experiment? Because we are conducting this too many times, like in repeated times and in identical condition. Okay. Now let's take a third experiment or a third example. Let's say the length of life of an electric bulb. We are talking about, wait, let me write. The length of life of an electric bulb produced by a certain manufacturer is recorded. Now in this case, one does not know what the exact length of the life of a bulb will be. However, one is aware in advance that it will be some number between 0 and infinity. Am I correct? Like if we just turn on the switch and we see the bulb diffused, so it will be 0. And if we just say that the life of the bulb is going on and on and on for life, like for infinity, then that can also be a case, but that is not an ideal case, right? So both are not ideal cases, but we take numbers between 0 and infinity. We can take any number, like the life can last till 1 year, 2 years, 6 months, 2 months, 2 days, anything, but it will be between this number. But we are not considering this fact. We are considering how many times we are measuring it. Like, however, one is aware in advance that the number will be between 0 and infinity, but one may measure the length of life as many bulbs as desired under essentially similar conditions. Now, we have talked about few examples here. Now, if I say, what is the remarks we got? Remarks is, the experiments described above have certain common features. For each experiment, we know in advance all the possible outcomes. Like this was the first thing which we observed, right? We knew the outcomes. We knew the outcomes. All right, which means that there were no surprises in store after any performance of the experiment. All right, however, we do not know what a specific outcome will be on any performance of the experiment. Did we know any specific outcome? The keywords which I'm writing here is very important because these are the words which you need to use in your exam for BSc papers. Okay, so yeah, did we know any specific outcome? No, we did not. So moreover, the experiment can be repeated under identical conditions. So this is the criteria for experiments, right? Now these features describe the notion of a random or statistical experiment because we did not know the outcome. Now again, we are talking about random experiment. Or like, let's not talk about random experiment at first. Let's talk about experiment only. Okay? Oh, this is highlighter. We need the eraser. Yes, this is the eraser. Now see, let's talk about some important terminologies at first. Important terms. The first important term is experiment. Now see, what is the exact definition of experiment? If an act or work can be performed more than once or repeatedly under essentially similar condition. similar condition, and the next is repeated. Then only it will be called an experiment. See, I'll take two examples again. If we toss an unbiased coin for like 10 times, what do you think this is? This is a random experiment. I'm talking about the types of experiment in disguise, all right? So yeah, just see, tossing an unbiased coin 10 times is a random experiment because we do not know what the outcomes are going to be. It can be 5 heads and 5 tails. It can be 6 heads and 4 tails. It can be anything. Now let's take another example, which will again be our second type. So let's see what is the example. Reacting two volumes of hydrogen, two volumes of hydrogen with one volume of oxygen. Is this an experiment? Of course, that is an experiment if we consider it like reacting two volumes of hydrogen with one volume of oxygen for all the students in a class. If every student needs to repeat this experiment, then this is an experiment. All right. Now, what is this? This is deterministic experiment. Why? Because we know the outcome. We know that the outcome will be H2O, water. All right. So these are the two types of experiments. Okay. Random experiment and deterministic experiment. We are not going to talk about deterministic experiment much in this semester or in this BSc course because probability always refers to the randomness, to the chance of the outcome. We need to require the answer, which is the chance of the outcome or the outcome which we do not know. All right. So this is not in our course. Just that I'm saying. If you need a definition still, deterministic experiment is what exact outcome can be predicted before performing the experiment. The exact outcome can be predicted. Wait a minute. Exact outcome can be predicted. Can be predicted. All right. Now we'll come to our next terminology, which is random experiment. Now here we're going to go deep. Okay. What is random experiment? We denote this as E. You have seen this in many books, right? So random experiment is denoted by E. Now, what is the definition? An experiment is said to be random if the set of all possible results of the experiment are known to us. Like we know all the results. Outcomes are known. All possible outcome. This is important. All possible outcome is known to us. But the exact result can't be predicted. Though we know all the possible outcomes, but we still cannot predict what the exact result will be. Can't predict the exact result. Like in other words, a random experiment is an experiment in which all possible results in an experiment is known in advance. And the next point is any performance of the experiment results in an outcome which can be predicted beforehand. And the third point is the experiment can be performed as many times as desired under identical condition. This is the definition of experiment only. No need to worry. Now we will come to the examples of random experiment. Let's take the first example. We're going to talk about coin in this example. Let's say, consider the experiment of tossing an unbiased coin twice. If the coin does not land on the sides, there are two possible outcomes, head and tail, which we denote by H. We are denoting by H. We can denote by anything. I am denoting it by H. You can denote it by 1 and tail by 2. You can denote it by anything, but you need to specify what you're denoting it with. Okay? Since I am doing it with H, I'm not writing 2. 1. Okay? Yes. So then all the possible outcomes of the experiment will be what? HH, HT, TH, and TT. You can write the result like this, or you can also write like this. Alright, in any performance of the experiment, one does not know what the exact outcome will be. Also, the experiment can be repeated as many times as desired under similar condition. Hence, what we observed is, tossing of an unbiased coin twice is a random experiment. So we proved it that it is a random experiment. Alright, now if we consider another example. Okay, consider the experiment of drawing a card. Now we are talking about card. Drawing a card at random from a well-shuffled deck of 52 cards. We all know that in a deck there are 52 cards, right? There are 4 suits, 13, 13, 13, 13. All right. Anyway, we know in advance all the 52 possible results. However, can we predict which card will be drawn in any specific draw? No, we cannot. Moreover, the experiment can be repeated as many times as desired under identical condition. Hence, drawing of a card from a full pack of cards is a random experiment. Is my explanation clear? Now, we'll talk about the next terminology, which is outcome. What is outcome? Each of the possible results of a random experiment is called an outcome. Each possible result of a random experiment is called an outcome. Let's take an example. Let's take the random experiment to be tossing of an unbiased coin twice. Tossing of an unbiased coin twice. Okay. Corresponding to E, there are four possible outcomes. Four possible outcomes, which are HH, HT, TH, and TT. This is how you need to write in the exam, okay? You need to mention first corresponding to E, there are four possible outcomes, and like that. Now coming to our next example, let's take a random experiment to be rolling of a fair die once. Rolling of a fair die only once. Now corresponding to E, there are six possible outcomes, which are 1, 2, 3, 4, 5, and 6, right? But you need to write like this, okay? Not like this in exam, or else your professor may cut marks for it. Now, let's come to our next terminology, which is sample space. What is sample space? The set or collection of all possible distinct outcomes. Distinct outcomes, elementary events. Like distinct outcomes can also be known as elementary events. Though I will prefer if you write distinct outcomes in exam hall. Anyway, exam paper. So what did I say? The set or collection of all possible distinct outcomes of a random experiment is called its sample space. It is usually denoted by S or omega. Okay. Now here we're gonna go deep into this topic, and we'll also understand a subtopic of it. First, let's take a basic example. A basic example is, let's take the random experiment to be tossing of an unbiased coin once. Okay, what will be the omega for it? I mean the sample space. What do you think? Nothing. Just H and T. H and T. Now, how do you need to write here? H and T, where H and T represents head and tail respectively. Please practice writing like this, because in our previous classes we did not do this. We just simply assume that H and T means head and tail. But that is not the case. You need to mention clearly, you need to specify clearly what you're taking as head and tail. Okay? So this is very important. We will go through every example. If you stay with me till the end of the class, you will know that you can practice well in your home too. Okay? Because we will write it many times in our class today. See, now the next experiment will be tossing the coin again, but here twice. How will you write it? Omega will be HH, HT, TH, and TT, where the first letter stands for the outcome corresponding to the first coin. Hey, wait a minute. First coin. And the second letter denotes the outcome corresponding to the second coin. Which is H and T respectively. No, not respectively. H and T representing. H and T representing head and tail respectively. Head and tail respectively. This is the full thing you need to write in your exam paper. Okay? So no shortcuts. Please write everything which I'm writing. Now, here we will understand. Now we will understand a subtopic which I was referring to earlier. Just dichotomous population. A very new thing for some of us. What is dichotomous population? Nothing but a general representation, okay, of how to understand the trick to understand the outcomes of tossing a coin or something, anything. General representation. My pen is acting up today, so please bear with me. General representation. Now see, for most of us, we remember the outcome for tossing a coin thrice, which is, we know it. The result will be, I'm writing it here in short, HHH, HTH, HHT, THH, TTH, TTT, and what? HTT and THT. These are the outcomes. Now, we will see in this example. Example means the representation. Let's take the serial numbers 0, 1, 2, 3. Okay, these are what? These are serial numbers. Now, the power of, like for this 0, we will write 2 to the power 0, here 2 to the power 1, 2 to the power 2, and 2 to the power 3. And this may continue for as many times you're asked to toss a coin or any question which requires two consecutive numbers like head and tail or defective, non-defective, anything. Okay, true, false, anything. 2 to the power 0 means 1, this means 2, this means 4, this means 8. How do we calculate it? Let's say for the first toss will be, here 1 means you need to write once. What does these mean? This means number of consecutive similar terms. Please understand, number of consecutive similar terms. So here for the first term, it is H and it is T. Only one is there. Okay. This is the outcome for the first result, for the first experiment. All right. Just as we have talked about, like tossing a coin once, the outcome will be H and T. Okay, very well. Now for the next one, tossing a coin twice. How will you write it? Here it is 2. Remember, number of consecutive similar terms is 2. Then we will write HH and TT. And how will we write here in this column? We will write again H and T. Then if I need to get the outcome of it, how will we get the outcome? HH, HT, TH and TT. Are they similar? Can we please see HH, HT, TH, TT? So yeah, we are getting it. This is working, right? The trick is working. Now coming to our next example, which I've discussed right here. Let's see if it works here. For the number 3, for consecutive number of similar terms, which is 3, we are tossing the coin thrice. It will be H, 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 and then T, T, T. And here what will be? It will be H, 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 T. All right. But wait. Okay. I've done something wrong. Let's correct it. Let's correct it. Let's correct it. Here it is 4, right? We need to write 4 times, not 3 times. 3 is the number of consecutive terms, like there's 1, 2, and 3. So we are tossing the coin thrice. But how many times will we write it? We'll write it 4. So H, 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 and then what? T, 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 T. So here it will be H, H, T, T, and here it will be H, T, H, T. This will be our outcome. Let's match it, okay? So our first will be H, 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 HHT, HTH, HTT, THH, THT, TTH, TTT. Alright, have I written the same thing? All 8 outcomes are here. Alright, now you can continue this saga for like 4 terms, 4 consecutive terms, or like 32 consecutive terms. It will be time taking, but you will get the answer correctly. Alright, if you want, I can do the 4th term, or you can do it on your home, on your own too. Like, what do you need to do for the, I'll just give you an example. Like, example means a little bit of hint. We need to give 8 outcomes. 8 outcomes means first H, H, this we will write 8 times. And then again we'll write for tail 8 times. And then we will fill up the other parts like this, how we're doing it for the other columns. So this is the thing, how you need to understand the outcomes. Now, what example can I take? Let's take another example. Okay, let's take the example of tossing an unbiased coin until a head appears. Until a head appears. Do you know how will we get the answer? Let's see this thing. First is head. Like we tossed a coin, and this is for the first experiment. So we just tossed a coin and we got head. So first will be head. Then what? For the next one, for twice, it is TH here. We are getting a head, and we'll stop it here. TH. Then for the third term, what will we take? We need one H to stop it. It will be what? It can be TTH. Only one head to stop it. T, T, H. And this will continue like T, 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 H. And then what? 4 terms, T, 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 H. This is a very easy trick to understand the result. Now, what did we find here? What is the observation? Observation is the outcomes is countably infinite. Countably infinite. Am I correct? Like this will go on. Then we will write 5 T's and then 1 H. This is the result for until a head appears. All right. How will we write it? How will we write the answer? We'll see. Same way, where the first letter, denotes the outcome of first toss. Second letter denotes the outcome of second toss. And so on. Which means H and T representing head and tail respectively. Am I correct? Yes. Now let's take another example, just the opposite. Like we will stop tossing of an unbiased coin until a tail appears. We just did head, now we'll do until a tail appears. Same trick. Like full same trick. How will we write it? Omega will be, first will be T, then H and T, then 2H, then T, then 3H, then we'll have a T, then 4H, then we'll have a T, and so on. And we'll write exactly the same thing, just change it. Like we'll say what? Where the first letter denotes the outcome of first toss, second letter denotes the outcome of second toss, and so on. H and T representing head and tail respectively. That's all. Now, if I take another 2 examples, I will take another 2 examples and we will wrap up the class. And the example will be tossing of an unbiased coin until 2 consecutive head comes. 2 consecutive head. We'll take help of that chart, dichotomous population. Okay, 2 consecutive head comes. This is also very simple. Like, just like the previous one, if you understand, I'll make you understand. Let's see. So the first outcome will be H and H, because that is our required answer, right? We need 2 consecutive head. So first will be H and H. Then what? T and H and H. Then what? T, T, H, H. Then what? H, T, H, H, and so on. Let's take this, see this in this chart. The first we have noticed is H and H for 2 outcomes, H and H, and then we noticed T, H, H. All right, and then for the fourth one we did not do, so it will be T, T, H, H, and then H, T, H, H. If you have completed this H, 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 and again there will be another rows and columns for H and T's, then you will find H, T, H, H. Do we get it here? H, T, H, H, yes, here. H, T, H, H. But for the T, T, H, H, we got it as our assumption only. Complete the chart to find out the answer, okay? Here, how will we write the answer? Where the first letter denotes the outcome of first toss, the second letter denotes the outcome of second toss, and so on. H and T representing head and tail respectively. Same thing. Now, what is the next example? The next example will be the same thing as the previous one. Just tossing of an unbiased coin until 2 consecutive tail comes. Consecutive tail comes. 2. And this is our random experiment. This will be exactly the same answer, just like this one. Just change the H to T, like TT, HTT, HH, TT, TH, TT, and so on. And then write the same thing where the first letter denotes the outcome of first toss, the second letter denotes the outcome of second toss, and so on. H and T representing head and tail respectively. Why am I saying the same line so many times repeatedly? This is also an experiment because I am saying an identical condition and repeatedly. So yeah, but I'm so sorry for the inconvenience. Yes, so, but this is something which is very important and you need to practice writing this statement as many times as possible, which is very helpful in exam point of view. So yeah, this is the end of our class. If you have liked the subject which I am teaching and if you have liked the content, please give me a like and share with your friends. And if you want, you can comment. Then it will be very helpful for me to understand your doubts. And if you have just appreciated the class, thank you so much to even write that. So yes, let's wrap up the class here. best of luck for this course and stay with me as long as I'm here. Happy learning. Bye bye. Take care.